Now, the agenda for the session today is very straightforward. I'll be introducing an investors panel. From there, the companies are gonna pitch. Each company's got 5 minutes to pitch, and then the investors panel are going to grill and drill and make them as uncomfortable as possible because they are all looking for money. So next up is GlassPoint, and we're fortunate to have Richard McKellar here. Now, Richard is a venture capitalist and recovering entrepreneur, which is an interesting statement, similar to one of our previous panelists going from investment banker to entrepreneur. He's a former managing partner with Chrysalix Energy Venture Capital and has board responsibilities in several startups. He was formerly CEO of 2 UBC spin-off companies, and Next Phase and Brightside. Prior to which he was an engineering manager for another startup. He actually teaches at UBC, where he's bringing the real life experience of startups and financing to entrepreneurs. And with GlassPoint, he's actually a director on the board of GlassPoint. Richard, the floor is yours.
Good morning. Thank you, Carl, for inviting me here, and looking forward to talking about GlassPoint. Carl asked me to talk about this because this is an example of mature technology being applied in the mining industry to decarbonize at a massive scale. You see a picture here. This is an installation with Petroleum Development Oman. So we heard about that in the last presentation. And it is about using solar power to create energy. As we look at the heat, the energy that's required in the world, the gray circle here is this is the total energy required. Industry is about 1/3 of that. And what is really hard to decarbonize is the heat element of it. Most of the energy is not required in the form of electricity. It's required in the form of heat, and it is really hard to decarbonize. And GlassPoint is a great example of doing this at scale, and the technology is mature. Now, when we think about this industrial heat, GlassPoint will work up to about 450 degrees Celsius, and that is about $444 billion of coal, of oil, of gas that's bought every year. And that number was put together before the price increases that we saw in the last year. So the market size here is absolutely enormous. The market opportunities, it's across the board. Wherever you need heat, not electricity, that's where GlassPoint can play. And of course, mining is one of the critical parts, and we're going to look at an example of that in a minute. But lots of other markets for this technology. This is Rio Tinto's Yarwun facility in Australia, and you can see a couple of big chimneys in the background there. Those are coal-fired power plants. Those coal-fired power plants burn 1 million tons of coal a year, and they produce 2.4 million tons of CO2. The opportunity here is to replace that coal-burning power plants with the solar thermal technology. So how does the technology work? Well, this is proven. What we're looking at here at the bottom is a curved mirror. The curved mirror catches the sun. It focuses it onto the pipe. It gives you 100 times the concentration of the sun on the pipe. And during the day, water flows through the pipe, it boils to steam, and it makes steam. To get the energy during the night, 2/3 of this plant has a molten salt flowing through it. The molten salt goes into a storage tank, and then a heat exchanger will take the heat out, and you can get the energy 24/7. And thermal storage using molten salts is a tiny fraction of the cost of electrical battery storage. So we have daytime steam, we have nighttime steam. And so how is Rio Tinto using this? Well, as you produce aluminum, the first stage of that is a digester, And in that, you're converting bauxite to aluminum hydrate. And it is steam at 290 degrees Celsius that's required in that process, and a lot of it, a huge amount of it, as you saw by those coal-fired power plants. Now, many of you may be familiar with solar thermal technology. You have a big mirror, you shine it, you heat things up. Well, this doesn't look like that. This looks completely different. It looks like a greenhouse. And that's because it is a greenhouse. And why the heck would you build a greenhouse for this? And that's because the inventors of this technology realized that the number one driver of cost of solar thermal technology is the wind. And when people go, how does the wind impact the cost of solar? That's very counterintuitive. Well, let me explain. There are two parts to it. So the greenhouse here that you're looking at protects the mirrors, but you'll also notice on top, there's a washing system. So what's the relevance of these two pieces? The competitive technology is on the left, and this is 30 kilograms a square meter to build these devices. The reason why they're so big and heavy is because when the wind blows, this is like a sail on a boat. There's a lot of power that is captured by a sail on a boat. So we need a lot of steel to hold the shape of that mirror. And we need a lot of concrete to stop it disappearing over the hill. So by building the greenhouse, we eliminate wind from the equation. It's all taken on the greenhouse. We lower the mirror weight by over 90%. And even when we add back the greenhouse, we've eliminated 50% of the steel and 80% of the concrete. So the capital costs drop massively by doing this. But there's a bigger advantage, and that's on the operating costs. When the wind blows, it puts dust on everything. This picture that you see here on the right-hand side, it's shown half of the greenhouse roof has been cleaned. That dust on the other half of the picture on the right is 1 day's buildup of dust. Now imagine that being directly on your mirror when it's exposed and not in the greenhouse. How do you clean a curved mirror? It's very hard. Whereas in this system, the mirrors are in a clean room. The cleaning system is like an inverted car wash, goes up and down the roof. It's all completely automated and it takes no people. I got a call one day from Arriva, who'd acquired Ozra. They'd built a system, a tiny system in India, and they had 400 people every night cleaning the mirrors, and all the water went into the ground, and they created a muddy quagmire. With this system, all the water is captured in the gutters on the roof, it gets cleaned and recycled, and it uses minimum amount of water. So this is the lowest capital cost, it's the lowest operating cost, and it happens to have the lowest land use area as well. If your mirrors are big and heavy and expensive, then you optimize for capturing the maximum amount of energy on the mirror, which means you space the mirrors apart and only cover 40% of the land area. With GlassPoint system, we're optimizing for the expensive component as well, which is the greenhouse. And so you're minimizing the area of the greenhouse. Your mirrors actually cover 93% of the land area. So lowest capital cost, lowest operating cost, lowest land area, and lowest water use. And proven at scale. So this is with Petroleum Development Oman. This has been operating since 2018, and this is 330 megawatts thermal of this plant. It's producing 2,000 tons of steam a day, and that water, that steam is injected into the oil well to reduce the viscosity and allow the oil to flow. Some of you may have seen an announcement that was made last year with Madden. This is another aluminum facility that is in Saudi Arabia. It's partially owned by Alcoa. And this is to build the largest solar thermal facility that will ever be built of any kind in the world. It's the equivalent of about 1.5 gigawatts of energy. It'll be about $1.5 billion of capital build. And the energy purchase that's happening with that, this is going to be an energy purchase agreement, a steam purchase agreement. It's about $5.9 $5.9 billion over 25 years on a take or pay contract. And that's one of a list of 5 projects that are in development at the moment, and a group of 16 projects that are under development, for a total of $1.5 billion of purchases of steam per year. So this is also a very experienced team. The mining industry is critical, geography is critical, the oil and gas industry is critical. Australia is a huge market. Malcolm Turnbull personally is an investor in this company. He's also an advisor to this company, and has a lot of work he does in the Australian market. We look at the aluminum industry as being critical. Thomas Sigurdsson was the former COO of Alcoa. He is personally an investor in this company and an advisor to it. And Matthias Bixel was on the executive board, one of the top 6 people within Shell. Again, he is a personal investor in the company. I'm also a personal investor in the company. And this is the team that actually runs the organization. Rod McGregor is the CEO. Rod has done 5 startup companies. He's had 1 tech superstar and dramatic crash as the bubble burst in 2000. But he's then had 4 successful companies, 1 IPO and 3 trade sales of those companies. And he leads this exceptional team across the board. So there's very few paths to really decarbonize the industrial heat market. And this is one that can do it. It can do it today, it can do it at scale, and the technology has been significantly proven. Driven by an experienced team in any application that fits within this temperature range, and it's highly economic out there. Now, I didn't put a slide on fundraising, but I'm sure that question is going to come up from our panel. So I could either wait for the question or address it now. Okay, thank you. So this company had an interesting history. I've known it for more than a decade. And in 2014, it had $1 million of revenue. In 2017, it had $100 million in revenue. We then had a couple of things happen to the company that caused it to go through a reorganization, which makes a really unique investment opportunity today. There was a combination of the founding CEO left, new CEO made some errors. The market, the big project that you saw in Oman, that was only 1/3 of the project. And the customer ran into difficulties, nothing to do with GlassPoint, and canceled the project. Project in California that was just starting, COVID hit and the funder pulled out. The company ran out of cash, which meant that this technology was so good, we should never have missed the opportunity of building it. So my role was to call up the debt holder, BlackRock, and say, if we brought the founding CEO back, the one that built it to 100 million, would you be interested in converting your debt to equity and relaunching? Then my next call, when they said yes, was to Rod McGregor saying, how's retirement going? And he goes, I'm bored out of my mind. I said, how'd you like to redo GlassPoint? He said, I'm in, that's fantastic. So brokered BlackRock and Rod coming together, we relaunched the company. Rod wrote the first check into the company, I wrote the second check, and Matthias Bixel, the advisor you saw on that page, wrote the 3rd check, and we relaunched this company. We've since done a relatively small raises in about the $5 million, which is going to be to build the rest of the team out. And we still have $2-3 million that we'd still take on that fundraising. We're about to move from an MOU signed with Madden to the real agreement, and they're going to put real money on the table. When we get that, there'll be a $35 million raise that is done to put all of the manufacturing back in place and complete the business development team that we've got. And then the next is going to be the project finance. And the project finance is big. The big project, $1.5 billion. It's going to be done in 3 phases of $500 million. So that's about 100 million of equity into projects and about $400 million of debt that's going to go into those projects. And we have a pipeline where it looks like there'll be about 2 of these projects per year. So for people who are interested in deploying significant capital, this is a tremendous opportunity. For people that are interested in what is a company that can change the energy profile in mining and many other interesting industries, this is a unique time to get in and become an investor.
Thank you, Richard, for that. Fascinating. You talked about the history of the company as well. Is there a pivot now to mining from, oil and gas? That was the previous focus, right?
Yes, the previous focus was in the oil and gas, and yes, there's a pivot to mining. And the thinking, one of the key changes, we made a couple of changes when we relaunched the company. One of them is instead of selling the equipment, so that previous one that you saw was sell the equipment, it's have a long-term PPA, a power purchase agreement with this one, or a steam purchase agreement in this case. So that's a significant shift. And then the other was, the future is not in oil and gas. The future is in the energy transition we're going to. And that energy transition is led by the mining industry. So let's focus on the mining industry. And aluminum is the first area that's happening there. But in the pipeline of projects that we have copper sulfide heap leaching projects, we have lithium brine projects, and we have soda ash, which produces glass, not metals, but it's a mining process as well.
Thank you. And then when I looked at, from your slides as well, which part of it is proprietary? Is it the automated washers? Is it the setup of the glass houses? What exactly is unique to the company?
Yeah, so what's interesting when you have a company like this and you look at a greenhouse and you go, well, that's obvious. And when you hear the story, you go, it's obvious. If it was so obvious, solar thermal systems have been around for a long, long time. But in the 1970s, with the oil crisis of 1973, was the first big push. Nobody came up with this idea. So the basic concept is actually patented. And there are 50 patents that cover the overall technology. And that is, we now hang mirrors from the ceiling. We don't put them on foundations in the ground. And that's how we eliminate the concrete. We've got, how do you actually go through the controls of things like this? How do you integrate this steam system with backup steam systems or existing steam systems? There's a whole pile of IP around that as well. So the 50 patents that there are cover all of these different areas that there are there.
Thank you.
So want to understand the competitive landscape in your view. So I'm worried that there are several other renewable thermal technology. People store heat in sands, in molten salts, and concrete or graphite, for example. But with your the temperature range that you're targeting and also the potential use infrastructure that you need, what would be the use cases or like what would be your competing, when you compete with customers, what you're targeting in the competitive landscape?
So the competitive landscape, there are a couple of elements to it. One is there's the solar field, and then there's the storage that you're talking about. But the biggest competitor, of course, today is coal, it's oil, it's gas. It's mainly coal and gas is the big competitor. Now, there are competitors in the solar space, and we're very confident where this company sits because of capital cost, operating costs, and land use. Each one of those becomes an advantage to the competition in different areas. When it comes to the day and night and storage, we don't care what the storage is particularly. We just go with the lowest cost for the particular location and application that we use and use a third party that's actually supplying that thermal storage system.
And one more question about technology development. Now that you mentioned it's a more mature technology, you're focusing on project financing to deploy project, commercialize the technology. Are you still working on any in terms of technology roadmap that you're improving, or it's just solely commercialization and deployment of this technology at the moment?
So What you saw there was a standard glass greenhouse. The next generation of greenhouses is the polymer-covered greenhouses, and we've actually built at scale a polymer version as well. The significant benefits of doing that in that it gives you more energy out, and those greenhouses are lower cost. So the system that's going to be built in Saudi Arabia is of that next generation of design. That's not new technology. What is new is the manufacturing elements of how you actually produce the pieces. So we're not going to go and build something of $500 million without first checking all that manufacturing stuff works. Now, so the system is going to be built sort of one complete scale unit. Does all the tooling work? Do all the parts come out the way you want? Does it assemble and go together as we expected? That's where some development is being done, but it's more, the fundamental engineering and manufacturing side of it.
Thank you for the presentation. Very interesting story. Given it seems to be there's a number of contracts or companies that have expressed interest in working with GlassPoint, and financing is available from a project financing standpoint. What are some of the risks that keep you up at night that could prevent the company from growing in part 2 of the journey?
Yeah. I think that financing is probably the biggest risk that there is out there, and access to land is the number 2. And then I think all the other risks are significantly less than those 2. So financing, it's never easy to convince people to part with money. And so we have a finance team. We've got Brian Gardner, who's the CFO there. We've got Andrea Woodkey, who has worked with Canadian Solar, worked with, going blank, other companies where they've done significant project finance, and they've done the taking companies public, because this company should go public not too far into this journey, probably a couple of years, 3 years from now. So I look at that as a risk. Now, access to land is a critical one, because as we talk to some of the mining companies, it's not a problem in the example with Madden. It's not a problem with the example with Rio Tinto in Australia. However, there are other projects in Australia that we would like to do where we're land constrained, and therefore you cannot do as much of the energy that you would like to do. You can only decarbonize a portion of it because we're land limited. And so that's where I see the largest 2 risks. The rest is the executional. Do you deliver on time? Do you deliver on budget? Does it have the performance you like? And on that, we've seen this team who have delivered on time, they've delivered on budget, and the performance of the system in Oman is at or above the rated capacity.
Awesome. Thank you, Richard and GlassPoint. And that was an interesting story, because what we see in mining and many other industries is it never worked, it failed, let's forget it. And Richard's story is very clear. This is just something we've got to keep going, rejuvenate it, and turn it into something different. So it's a really cool story.